So let's go to RAS fundamentals. These are the content of this module. So number one is introduction to RAS. What is RAS and why use it, and setting up the RAS environment. Number two is RAS syntax and basics. It talks about variables, data types, control structure like if, loop, and while. Number three is the ownership and borrowing, understanding RAS, memory management. And number four is a hands-on activity. Supposedly it's a one-day event, module, but I thought it would be a one day since we don't have the speaker for blockchain as of the moment. So I'll try to compress it into the modules covers to 3 to 4 hours, but hopefully we can compress it since it's a big topic. So number 4 is number 5 is that structs and enums, defining and using structs, defining and using enums. Number 6 is error handling, results and option types, panic and recovery, concurrency in RAS, threads and async programming, and lastly, the hands-on activity. So again, welcome to RAS programming. So RAS programming language helps you write faster and more reliable software. RAS is known for establishing the development of faster and more reliable software due to several key principles such as memory safety without garbage collection, performance, concurrency, toolings, and strong type system. In programming language, the trade-off between high-level ergonomics and low-level control is a fundamental considerations. These trade-offs involves balancing the ease of use and expressiveness of language against the ability to manipulate hardware and system resource directly. So high-level ergonomics. High-level ergonomics refers to the features and abstractions provided by programming language that makes it easier for a developer to write, read, and maintain code. These features includes abstract data types. High-level language provides built-in data types and structures like lists, dictionaries that simplify complex operations. Garbage collection. Automatic memory management frees the developer from manual memory allocation and deallocation. Rich standard library, a comprehensive set of pre-written functions and modules that can be readily used to perform common tasks. Expressiveness. Syntax and language constructs that are close to human language or mathematical notation, making the code more readable and writable. And lastly, error handling, built-in mechanisms for handling errors and exceptions in consistent manner. Example of this language is Python, JavaScript, Ruby, and others. So for low-level controls, it refers to the programming language to provide direct access to hardware, system resources. This allows developers to write highly optimized and efficient code. Key aspects of low-level control includes manual memory management, direct hardware access, performance optimization, system calls, and interruption. One of these examples is C and assembly. The trade-offs. This is the trade-offs between these two high-level ergonomics and low-level control. The trade-offs are abstraction versus control, high-level language abstraction, away the details of the hardware, making it easier to write code, but the cost of losing fine-grained control. Low-level language provides more control, but require more effort to manage these details. Ease of use versus performance. High-level languages prioritize ease of use, which can introduce performance overhead due to abstraction like garbage collection, and dynamic typing. Low-level language can achieve higher performance by avoiding such overhead but are more flexible to use. Safety versus flexibility. High-level language often includes safety features such as bounds checking and automatic memory management, reducing the risk of error. Low-level language gives flexibility, which can lead to error if it doesn't manage carefully. So in Rust, this conflict is being challenged. So without further ado, let's get started with Rust. That's a brief introduction to Rust. So first, we need to have our environment set up. I assume, or do we have already the environment set up? Or okay. So I assume that we already did install the what is here in the Rust installation guide. It's just a minimum requirement for us to run Rust and create projects. I'll be using Linux, but it's just the difference is just minimal in terms of installation. Since whatever we have for Windows, I already give you the link to install the environment here. So it's just simple installation. Hopefully it works in your machine. So I'll install it in Rust. Then, in Linux. Then I'll go around to assist you for your installation. Okay. Okay. I did check some of the pieces here. So for this module, Rust Fundamentals, we only need Rust C to be installed in your machine. That's the only requirement that I have for this module. So if you kindly check it in your local machine by using this command rust c dash dash version, then if you have it shows you the result of your Rust version, then we're good. So we can proceed to our lessons. So kindly check it in your local machine. If you are using WSL, so just go to your terminal, then run this command, rust c dash dash version. Command. Okay. So I think everyone already has the required environment for us to proceed. So let's continue. So let's write hello world program. So for this instance, first you need your terminal open. Now that we have installed Rust, it's time to write our first program. It's one of our tradition when learning new language. We write a little program that prints the text "Hello World" to the screen. So let's start. So first we need to create a directory in your name projects. These are the instructions. First, you need to create a directory in your home directory name projects. Then cd to that directory and create another folder and navigate to that directory. So first, we need to have a project directory. Then cd to that directory. Then create another directory named Hello World. Then let's now create our first program using Rust. your Visual Studio Code so you can easily create that uh, file. So, so I already created using touch command to create this main. Actually, it's not RTS but RS. Then let's write our first program. Okay, then save the program. So the second part is we need to, in order to run the program, we need to build it so that it will produce an executable file, and from there we will run the actual program. By doing so, I just type rasc, then the name of the file. Using this command, it will produce an executable file. This main file here is an executable. Then we can run it by calling this path. Okay. Who among you was able to run your first program in RAS? Any hand? Okay. Welcome, and you're officially a RAS programmer for those who successfully ran our first program. What we did here is just a manual of from creating directory, hello underscore world, and creating our first program, main.rs. We did it manually. So if imagine if we do this in this way, and we have this dako kayo nga project, so hassle kayo in the way of managing the files and other stuff like the dependencies that we'll be using. So we'll be using it or dealing with it manually. But there's another approach in creating RAS project. So let's jump to the easier one. Before proceeding to the using cargo and building RAS project, let's just first dive into the RAS program anatomy. So let's review this Hello World program that we wrote a while ago. So here's the piece of the puzzle, like the fn main function. So these lines define function named main. The main function is special. It's always the first code that runs in every executable RAS program. The function body is wrapped in curly braces, open and close. RAS requires curly brackets around all function bodies. Then the body, which we wrote the print ln to print the hello world. So this, as you can see, this syntax is common to other languages. So there's no much difference, like C++, or JavaScript. So it's not that hard to adopt, since the syntax of RAS is just merely same from other languages. So let's build our RAS program using cargo. So it's more easier if you use cargo. So before that, let's check first if you have cargo installed in your local. Just run cargo -- version. If you found if it's all returns a version, then very good to go. So do we have cargo installed? Okay. So let's now create our project using cargo. So the first command creates a new directory project called hello cargo. We've named our project hello cargo so that it will have distinction from the previous one. Then if we then go to the newly created project, okay. So by running cargo new hello cargo, so it produces two files for us. One is the cargo.ml, and the one is a directory is src. So let's go first to cargo.ml file and let's check if what's inside. So as we can see, file has this details. So in order for a RAS project to be created, so we need to have this first line, then the next three lines will define the projects that you'll be creating. First, you need the name, the version, and the edition. It refers to this edition part here. It refers to the RAS edition that we are using. Then the last part is the dependencies. This part here, after dependencies, we will be all the packages or dependencies that we'll be using will be added after the dependencies. Okay, let's jump to the source directory. In our source directory, we have our main program. If we dive into the main RS file, so we have our template program, which is function main, print ln, exclamation point, then open close hello world. So using cargo new hello cargo command, so it gives us this project template to start with. It will be a lot easier if we use cargo in building our projects. Then afterwards is the building part. Okay, we already created our first project, second project using cargo. Then let's now build and run our cargo project. First, we need to build it. So the one we did before is we call our RAS C, then calling the file of the file name of the program. Then here, we just use cargo command, cargo build to build our program. When we build in our first project, we use this command to create that executable file. So right now we use cargo build to create that executable file. So if we check our directory, so we have new files created. So one is the cargo lock and the other one is the target. So your cargo lock, this file here, it will be automatically created as you build your project. So cargo.lock contains the information of your project during that build. So let's go check cargo.lock. This is the information that we have for our first build. So it's version 3, name is hello cargo, then the version of this program. Then we have a target directory that contains our executable file. So since by default, when we build a RAS project, it is built in debug mode. Then the same way we did in our first project, we just call this executable file, hello world, then we have our programs running now. But if you are in the root directory, you can so this part here is we did it manually running the program. But there's another command that will build and run the program so that we will not undergo this process, additional steps in just building and running the program. So we will use this command. So by running cargo run, so first what it does is it builds and create an executable file. then it runs for us. So here we have our executable file created. Then if you want to check, just check your program without uh, building an executable file. So you just need to run this command. So here it bypassed the creation of executable file and the running of our program. So it just merely check if our program is running. So in this command, it's more easier for us to check if our program is actually running for this. So just to recap, so we have our first command for cargo, which is the cargo new hello. Cargo new, then the name of the project. Then the next one is the cargo build, building the project and creating it an executable file. Then the third one is the cargo run, which automatically create our executable file and run the program for us. And lastly, we have, if we want to build it for release, for production release, so we just need to run this command, cargo build dash dash release. So for cargo build dash dash release, so it will also create another file for us, our directory, which is inside target, then inside release directory. So we have our production ready program, which is the hello underscore cargo. So same process, we just run this the same we did with the debug version. So for cargo as a convention, working in any existing project, you can use the following command to check out the code using Git or change the project directory in the future. In working with existing projects, so I assume that you have GitHub's or this scenario is referring to if we have GitHub accounts, then the existing repository is on the remote. So first we just need to run this code. Before we clone, let's just go back to our parent directory, which is the... before we clone it, we just go back to our parent directory. Okay, we just clone our existing projects, then let's go to that directory. So here, since it's an existing project, so that's why we have here our cargo.log file and a README file that generated from GitHub, then our source directory. As you can see, we don't have the target directory. So when we push an existing project to the cloud, so we remove this target directory since it contains all our dependencies. So it will be bulky if we push it or save it to the remote repository. So in order to produce that target file, so we just need to run cargo build. So you can do that if you if you have GitHub account, then you just need to set up it locally. But since it's a common PC, so I advise not to do it so that others might have access to your. But it's just the same process that we have aside from cloning the remote repository. So we just cargo build, then same part, it just produce the target file that we need that contains all the dependencies and also the executable file that we need in running our program. So now we have successfully run our existing project based on the repository that we cloned from GitHub. So, nakapalo ra tanan. But more or less, it's just the same process aside from the Git. So, Cargo as a convention. With simple projects, Cargo doesn't provide a lot of value over just using Rust C, but it will prove its worth as your program becomes more intricate. Once the programs grow to multiple files or need dependencies, it's much easier to let Cargo coordinate and do the build for us. Even though the Hello World project is simple, it it now uses much of the real tooling you'll use in the rest of your Rust career. In fact, to work on an existing project, you can use what we just showed you earlier. So what we did is from creating your first project down to building and creating the release file, it's the convention that we Rust developer do globally. So it's the standard of doing Rust project. So in summary, we already off to a great start on our Rust journey. In this section, we've learned how to install Rust and its latest version, update to new Rust version, write and run a Hello World program using Rust directly, and creating and run a new project using the convention of Cargo.